Hello everyone, my name is Jobin. I'm working for Percona as Postgres. So can you all hear me without a microphone? Yeah, then I prefer not to use. Yes. So I'm into Postgres community for quite a long time. Today I'm talking about the title is so big, but don't worry about that. This is a continuation of what I'd done in New York, the Postgres conference. So in the conference, I asked, even in India, I asked a random question how many of you are aware of there is a built-in sharding feature coming into Postgres? It's not at matured, but yeah, the work is in progress. So today's my talk is about that piece. So today I'm going to talk about the importance of Postgres FDW, the foreign data wrapper, and some basic introduction, some of the new features getting introduced into the FDW, and how this Postgres FDW can participate in SQL plan. Suppose you have a SQL and where each of the table or partition can be coming from different shards, basically. Yeah, so how it can be possible, and how these partitions of a table can be pushed into remote servers, divide the data. And I'm planning to have a quick demo. I don't know whether I'll get time, but yeah. And there are a few areas still need work, so we are going to quickly look into that. And today we are not going to talk about advanced sharding, which is possible through other extensions like Citus or Timescale. So that's not the topic today, so please excuse me. Yeah, so the entire sharding requires multiple Postgres instances to communicate each other. So you have, say, one side one master, another side another piece. So they should talk each other and distribute the data or give the answers to some queries. So that is the basic requirement. So that is where the Postgres FDW comes, enabling the Postgres to talk to other Postgres instance. And the FDW stands for, as I mentioned, is a foreign data wrapper, and it is not a Postgres only feature. It is first appeared as a ANSI SQL standard in 2003, and every database is supposed to implement that. So in Postgres, it appeared in version 9.1, and there are two parts of that specification. One is management of external data. So you have some data sitting in other database, and you want to get the data for your queries to get the answer. And the second part of the specification is all about foreign tables and data links. Means, so normally a database system will store data into its own data files, and it manages those data files, the database system. But this specification tells about how a database can talk to a set of files outside the database system. Say, for example, you have a spreadsheet sitting outside, and you want to query the data using your thing. Yeah, so that specification is there. So Postgres FDW is first implemented as a reference implementation of this specification, and other FDWs, say you can join tables with the MySQL or Mongo also. So there are FDWs for almost every data sources. Even there is FDW for S3 bucket. So there are hundreds of foreign data wrappers. So this Postgres FDW is a reference implementation of the foreign data wrapper. And it is maintained by Postgres global development community. So other data wrappers are maintained by their own community. So Postgres is an ecosystem. There are small groups, and they develop their own things. Yeah, but this piece is maintained by Postgres community itself, that main community itself, and it is available as part of contrib modules. So most of the Postgres distributions, you will get it as part of your installation itself. You don't have to install anything else. And some of the distributions like Red Hat clones, they pack it separately. So it is a simple installation. You can say yum install Postgres 11 contrib module. All the contrib modules will be available to you. And the Postgres extension, maybe most of you already know how to create an extension. It's a single command, create extension and extension name. So once we have this extension in place, your Postgres instance can talk to other Postgres instances. So that is the idea behind the sharding. So let's look at some of the improvements. We already talked that it came in 9.1, and as a community we won't be having a big change. Slowly all the features will be improving step by step. So we are going to see some of the improvements. So optimization of remote query. So I took a execution plan of a very big query, and here you can see there is a remote SQL execution. This actually goes to the remote server, and here what we can see is it is pulling only one column from the remote server, because this server knows that what are the columns of the remote server. So it can only pick that particular value from the remote server, and if this column is indexed in the remote server, it can the further optimization is possible in the remote server. So we can leave it to the remote server. And FDW can do remote writes. So when we shard the data, we need not be doing the transaction in that shard itself. We can do the transaction here itself. Here is an example. Here we can see as part of execution plan, the update is getting executed in the remote server. Okay, and operator and the function push down. All these things are coming with the later versions, new versions of Postgres. So instead of pulling all the rows from the remote server and doing the calculation here in the local machine, we can actually push many of these things to remote machine. So here we can see two things. Say this filter condition is pushed down. That is less than operator. Greater than operator. It is sent to the remote machine, and the comparison is done there. And only those data will be pulled here, and even the average operation will be performed in the remote machine. So end of the day, you will see that only very minimal data getting transmitted from the remote shard to your machine. So the network overhead will be very minimal. And join push down. So the join operation also can be performed in the remote machine. A part of the join, say if you are having properly partitioned and sharded table, the join operation can be performed in the remote machine. So this saves a lot of dividing the computation, spread the computation load to multiple machines. And the predicate push down. So the where clause and aggregate functions, see the count star will be executed there. So now we talked about how the Postgres can communicate each other for executing a single query on a machine. Now we can go and see what is the improvement happens in partitioning. So now the latest Postgres has all complete partitioning features of Oracle, like list, range, and hash partitions, and now it is possible to do partition-wise scanning and partition-wise index and partition-wise joining. All these things are possible, and all these things can be clubbed with the shards. So all the benefit of declarative partition can be clubbed with the sharding feature. So these are the areas where currently we are doing, we are seeing the improvements. So partitions in remote servers. So that becomes shard. So in the new versions, you can see a SQL syntax like this. Create foreign table, not normal table, foreign table, and we need to give the table name of that partition and partition of parent table. So the foreign table is something we are telling that telling to our Postgres instance that we have a foreign table which is partition of this table but sitting somewhere there. So the connection information, all those things can be specified here. So this is standard syntax. So the entire story so far, FDW is becoming more and more powerful enough to handle and become intelligent to participate in SQL query execution and execute each part of the SQL very intelligently. And the partitioning features are improving, and the planner is SQL planner also becoming more intelligent to divide all these things. And now it is possible to have partitions in remote instance. And one more thing which I didn't speak here because it is still in discussion. It is the parallel execution. Already you know Postgres has parallel execution possible in Postgres, and that framework is there in Postgres. Now they have planned to integrate those things also to this. So all the partitions can be parallelly scanned instead of doing one by one. Okay. And I was planning for a demo, but we don't have time. Yeah. So the further working area is the parallel execution, as I mentioned. So the planner need to schedule it for each of the threads, create a parallel worker threads and schedule it, and some improvements. And there is one area where still under discussion is multi-node transactions. So now, you know, the say if there is a transaction which updates multiple nodes, so then it need to be coordinated in a, or it need to be ACID compliance is required. So those areas are in progress. Yeah. So do we have 2 minutes time? Yeah. So let me show a quick demo. Oh, sorry, I can't. My laptop has some problem. Yeah. So because we were doing the presentation here. Sorry about that. Yeah. So any questions you want to ask?
By multi-node transactions, do you mean that I start a transaction in a node and I can continue in another?
So currently the limitation is it is if there is a remote transaction,
okay,
it cannot be rolled back. So if it is committed there, so if there is update statement goes to the remote machine, it will be committed there. It cannot be rolled back. The rollback thing from the planner is not implemented. Yeah.
okay.
So there is little more. Yeah.
So you showed the syntax for creating a foreign table as a partition.
Yeah.
Is there a matching syntax for exchange partition? So if we use something like import foreign schema, can you make that a partition? Or you still need to do the whole long form?
Yeah, so you mean the transferring of some partition from local machine to remote machine?
Well, not even that. Just use the import foreign schema function to create your foreign table,
yeah,
and then make it a partition. So you don't have to type out.
Yeah, so there is a like syntax. Is create table. There is a like syntax, so you don't have to specify the columns, all those things. Yeah, yeah, that's a good question. Yeah. Any other questions?
So if you go sharding between 10 shards,
Okay.
how do you specify that it's going to A and not to F or D?
Yeah, so the talk is all about what is maturing in the Postgres database side. So what are the infrastructure we are developing. So the ultimate solution, like so the splitting of things, it need to be scripted or automated. That's it coming in. So now we can do pretty much all the things by command line. Okay, create this shard here, split it. Yeah, manually we need to do that. But yeah, automation is really possible. Infrastructure is getting ready. Yeah. So even we can write an extension for that, yeah. Cool?
Yes. Thank you.
Thank you.
Thank you.